welcome to the fifth session under Unit 2. In this session, we'll be talking about amine compounds. At the end of the session, you should be able to use qualitative tests to identify amine compounds. So you quickly look at what amine compounds are. I'm pretty sure you know of amine compounds, right? And they are organic derivatives of ammonia, and you mostly have one or two of their hydrogen groups being replaced with a carbon. So either an aliphatic or an aromatic functional group. So we have the primary amines, secondary amines, and of course the tertiary amines. Right. Now amines have an unshared pair of electrons on the nitrogen, and therefore they act as bases. They can also act as nucleophiles, and in some cases they act as compounds that can be oxidized. So as Lewis bases, they form salts with acids, and they form coordination complexes with metal cations. And as nucleophiles, they displace halogens from alkyl halides and acyl halides to give more highly alkylated amines and amides, respectively. They may also be oxidized by a variety of oxidizing agents such as permanganate, oxygen, hydrogen peroxide, and then nitrous acid. So in the test for amines, there's this acid chloride test, which is also known as the acyl chloride test. And here, amines as nucleophiles will react with this acid chlorides or acyl chlorides to give amides. So this reaction can be used to indicate the possibility of an amine functional group in a compound. Now the suspected amine is added to benzoyl chloride, and then as the reaction occurs, heat is released, right, and the test tube gets warm. So we have the typical equation of the reaction here. So during the course of this reaction, hydrogen gas is evolved or is formed, but but it doesn't actually bubble out of the solution. So this gas doesn't bubble out of solution as is observed because the hydrogen chloride reacts with unreacted amine to form hydrochloride salt. Okay, so next we can look at the Hinsberg test, and here it's basically a reaction of our amine with benzene sulfonyl chloride to form sulfonyl amides, also known as sulfonamide, right? And this can be used to tell if our amine is a primary amine, a secondary amine, or a tertiary amine. So the sulfonamide from the primary amine has an acidic hydrogen and dissolves in sodium hydroxide solution, whereas the secondary sulfonamides that are produced from the Hinsberg text lack this ability to form hydrogens that will dissolve in sodium hydroxide, right? So the product formed is insoluble in basic solutions. The basic solution here is our sodium hydroxide. And our tertiary amines do not form sulfonamides at all in the first place. So we need to keep note of these three difference. So the Hinsberg test can be used to identify primary amines, secondary amines, and tertiary amines. Okay, so next is to look at our nitrous acid test. Now, nitrous acid test, especially with primary amines, when they react with nitrous acids, they result in the formation of a diazonium salt. Now, this diazonium salt is unstable and therefore quickly decomposes to give the carbonium ion and nitrogen gas, with the nitrogen gas being rapidly bubbled out of solution. Now, with the secondary amines, they do not form the diazonium salt upon the treatment with nitrous acid. So when you react the secondary amines with your nitrous acid, they do not form diazonium salts. However, they do form nitroso compounds, which will then precipitate out of solution as yellow oils or solids. So that is the difference between reacting your amine with your primary amine with nitrous acid and your secondary amine with a nitrous acid. However, tertiary amines do not react in this manner with the nitrous acid. So in your model, in the and then of course in the lab, the this procedure was performed. This procedure was used to to identify your unknown amine. So if it was a solid, then you need 100 milligram of it. However, if it's liquid, you need zero point 0.1 mil of it, and then you add your P to toluene, sulfonal chloride, and then 5 mil of the 10% base. In this case, so either sodium hydroxide or potassium hydroxide can be used. So you transfer this into a test tube, stopper it, and shake it for several minutes, and then you can take off the stopper and heat the mixture in a steam bath for about a minute. So right, you allow it to cool, and then you check if it is not a basic pH. If your solution is not basic enough, then you can still add some amount of your base, in this case the potassium hydroxide or the sodium hydroxide, to it to make the solution a basic solution. Now, if a precipitate has formed, then you add 5 ml of water and then shake vigorously to test for its solubility in water. So, if the precipitate does not redissolve in the basic solution, it is an indicative that the product form is a sulfonamide of a secondary amine. However, there's if there's no precipitate, right, then you have to add 5% HCl until the solution is just acidic, and then you test that with a pH paper. So you add acid to the solution, about 5% to the solution, and then you check. So the formation of a precipitate under acidic conditions suggests that the previously formed soluble sulfonamide was a primary amine, right? So just as I said, if a precipitate does not form, then you redissolve it with a base, and then it dissolves, then it means it's a secondary amine. However, if no precipitate forms, right, uh, and then you add an acid before the precipitate is formed, then it means the amine is a primary amine. So if no precipitate has formed at all, then the initial amine could have been a tertiary amine. So just as I said, the sulfonal, your p-toluene sulfonal chloride will not even react at all to form any precipitate in the first place if it's a tertiary amine.